This question comes from Alina, who asks, what if you could commute between Earth and Mars every day? So you live on Earth but work on Mars. Every morning you travel 140 million miles to the office, then come back home for dinner. Let's see why this is a spectacularly bad idea. The distance between Earth and Mars varies wildly, anywhere from 34 million miles at closest approach to 250 million miles when they're on opposite sides of the Sun. Let's use the average, about 140 million miles. Current spacecraft travel at roughly 24,000 miles per hour. At that speed, your one-way commute takes 243 days. You'd spend 486 days commuting to work for an 8-hour shift. This is objectively worse than the New Jersey Turnpike at rush hour. Okay, what if we go faster? Let's use something actually quick, say 1% the speed of light. That's roughly 6.7 million miles per hour. Now your commute drops to about 21 minutes each way. Not terrible, except for the radiation. Space is filled with cosmic rays, high-energy particles that shred DNA. Earth's magnetic field protects us, but in open space you're exposed. A 2017 NASA study found that a round-trip Mars mission exposes astronauts to about 0.66 sieverts of radiation, roughly equivalent to getting 200 chest x-rays. That's for a one-time trip. You're doing this daily. After a year of commuting, you've absorbed about 240 sieverts. For reference, 5 sieverts is lethal. You develop acute radiation sickness within weeks and die from cancer within months. But let's ignore biology and focus on physics. What if we could go even faster, say half the speed of light? Your commute is now under 5 minutes each way. Fantastic. Except now relativity becomes a problem. At 0.5 c, time dilation kicks in. Einstein's equations show that time passes about 13% slower for you than people on Earth. After 1 year of your daily commute, Earth is aged 1.13 years. Your spouse and kids are aging faster than you. Attend your daughter's birthday party, and she's mysteriously older than she should be. Also, fuel. Accelerating even a small spacecraft to 99% light speed requires energy equivalent to several nuclear bombs. Doing this twice a day, once each direction, means you're consuming the energy output of a small country just to get to work. A physicist I spoke with calculated the cost, roughly $400 trillion per day in energy expenses. For comparison, the entire global GDP is about $100 trillion per year. And we haven't discussed deceleration. If you're traveling at half the speed of light and need to stop at Mars, you need to slow down. At 1 g of comfortable deceleration, roughly what astronauts can tolerate, you'd need about 24 days to safely stop. So you'd spend 24 days slowing down, work for 8 hours, and then spend another 24 days accelerating back. Your daily commute now takes 48 days. Here's the real problem: orbital mechanics. Earth and Mars are constantly moving. They're not sitting still waiting for you. By the time you arrive at Mars, it's moved. You need to constantly recalculate trajectories, burning even more fuel just to hit a moving target. An orbital dynamics researcher told me it's like trying to throw a ball from a moving car to another moving car, except both cars are going different speeds in different directions, and you're throwing at half the speed of light. So could you commute between Earth and Mars daily? At realistic speeds, your commute takes longer than human lifespans. At relativistic speeds, you age slower than everyone you know. At any speed, the energy costs bankrupt nations and the radiation kills you within months. The average American commute is 27 minutes. Complain about that if you want, but at least you're not aging at the different rate than your family while absorbing lethal radiation and spending more than global GDP on fuel. Turns out Earth to Mars commuting makes rush hour traffic look pretty reasonable.